Hey everyone, my name is Vinicius. I'm a software developer at AE Studio. I work mostly with blockchain, a lot of NFT projects, and today I'm going to show you guys how to create your own generative NFT. Really hands-on talk, so I'm not going to explain like in details how NFT and blockchain works and the technologies because the talk before this, Batista just did it, so he explained the fundamentals and this talk is just like to show you how to do it in like a real simple app that you can do it. So the first thing that we are going to do is to create the art. So to create the art, we are going to use generative art. So we have the layers, and then we are going to assemble our art, and then we are going to create the smart contract, and finally creating an app to mint the token. So the first thing that I'm going to introduce here is Hashlips. So Hashlips is a well-known NFT collection in the crypto space. So you can see here that they have basically these lips with different colors and some objects. So the way they do, they have some different layers like images. So they have like the background separated, and they have different backgrounds. So this one is green, this one has some theme. So they can assemble this using some art engine to create a final artwork. So I'm going to use the same approach here. They have this engine here on GitHub. It's a really nice open source engine. So I already downloaded and installed the dependencies, and I'm going to open here because we have to do some changes to create our art. So I open here. We can see here in the layers that they have all the layers that I talked about. So they have different layers that in the end they will be assembled in the artwork. So the first thing that I'm going to do is it's deleting these layers and adding mines. So I'm just going to delete these layers, and I'm going to have mines here. So I have these layers here. There are like some images that a designer here at AE did for us. It's just like the AE logo with different colors and themes. So the first thing that we have to do after having the layers here is the images. We have to open the config file because we have to change some configs. Here we have like the name of the collection. Let's say it's my awesome NFT, and the description is made with love by AE. And here we also have the base URL. That's basically where in the metadata will live. So I will explain this better later, but basically the NFT will point to this URL here with the ID, and then basically that's where the NFT lives, the metadata. So in this case, I'm not going to use IPFS because it will be more work to do with IPFS. I'm just going to use like a local API, but you should use IPFS to have a decentralized storage. It's not the best approach to use like an API because they can change the metadata later. But in this case, I'm just going to use like localhost in the port the default byte next, and then API. So so this is where they will point my metadata, and then here we have to change the layer configurations. So I'm going to create like 10 NFTs, and here I have to name the layers. So the layers that I have here will be background, then square, and then also, no, it's triangle first and then square because there's an order here. And with this we can already generate the NFTs. So I'm going to go here and use the command to generate. You can see that it's running. It will create the editions. So we can see here in the build folder that we have the images. So we have here the images that it created. It's kind of big, so it kind of pixelated, but that's the idea. And here we have also the JSON file. That's the file that I'm talking about. So in the end, basically, this is your NFT. There is a link on the blockchain pointing to this metadata JSON. So basically, that's the NFT in a really simple way. And here is like the API that I talked about, where it's going to be your files, like your images. So with this, we already have like the images. We can even create like a preview GIF. Oops, wrong folder. We can see here like the preview GIF. So basically, that's it from the Dart engine. I'm just going to uh, change another thing here because it's starting from 1, and I'm a programmer, so I think it should start from 0. So I'm just changing this number here, but that's just a minor thing, and I will generate it again. So we can see now that start from 0, and also it's a completely new image as well. Every time that you uh, generate, it will generate based on the some random probability. So with this, we already have the build folder that we need with the images and the JSON. That's basically the NFT. So we're going to move to the smart contract now. So we are going to use ERC 721. That's basically the standard for NFTs with one quantity. So this is a pattern defined by the Ethereum community. So we can go here. We can go here to Open Zeppelin. Like Open Zeppelin, it's it's a company that provides services and also open source implementations of contracts. So it's the standard for secure blockchain applications. So it's a library of modular, reusable, and secure smart contracts rating solidity. It's basically the most popular library in the industry. So it's good to use like a well-known code that has been tested and audited. So it's pretty simple to create your contracts with that. Also, we're going to use a tool from OpenZeppelin called Wizard. So I'm just gonna open here the wizard. So it's the contracts wizard. It's really simple. You can choose which contracts we're going to use. In this case, we are going to use the ERC 721. And here you just like have to check the things that you want, and then we'll create the token for you. So in this case, the base URI is the same that I explained to you guys. Is localhost, but it should be IPFS in the real world. It's just like uh, to make it simple, I'm using the localhost API. And then we're gonna have to be mintable with auto increment IDs. So with mintable, we can create new NFTs, and that's basically what we want. We're going to create like an app to the user, like mint NFTs. We're going to check also the enumerable. So the enumerable has some functions, some methods that makes life easier to know from one user which NFT he wants, and also the URI storage. That's basically another thing to concatenate this base URI with the ID, so it will land on our API, and we can see like the metadata from this token. So that's basically it from the wizard. We can copy this code, and I'm going to open another project here. Right now it's just like a next app, really basic, but it doesn't matter right now. I'm just going to use the same the same repo for everything to make life easier. So I'm going to create a folder here called contracts, and also a file here called my token, a solid file, and paste the thing that we just had. And also here we're gonna replace the safe mint function to a claim function. So the idea here is instead of being like just minting, you have to pay a fee to mint your NFT. So if some user go here and pay some fee, he will be able to get his NFT. So it's a public method, it's also payable, so we can send money to this method. And here we're gonna have like basically the same thing as here. We're gonna have the token ID here first, and then also the price that we want. Um, in this case will be 0.2 ether because it's EVM. So basically it's like 0.2 the coin of the chain we're using. Also, we're going to require that the message value should be equal the price that we are setting. Otherwise, it will fail, like invalid amount. I'm sorry, it's just supposed to be just double. Also, we're gonna require the token ID to be less than the max mintable, so we don't have no more NFT availables. Actually, you have to define this max mintable. I don't think we had yet. So I'm just gonna go up here and declare as public as well, max mintable. Let's say it's 10. And also I'm going to declare another variable here to be our like a treasure. So it's an address, it's payable, and let's call it treasure. So it's where the money is going to go. So it's payable, and here I'm just gonna copy my address from my wallet. So we can go back to the claim function. And so right now what we need to do is move the money. So we have the treasure, and then transfer the amount of the price that we are receiving on this function. And then we can, oops, and then we can safe mint the token to the sender with the token ID. And finally, we increment the token ID just like the safe mint. And we can delete the safe mint because we don't need it. So basically, that's the contract. It's saying that we will. So basically, that's the contract. We have the claim function. It expects to be to send some money to it, and then if it has the right amount, it will transfer. Oh, I have to install the dependencies here. It doesn't found the Open Zeppelin contracts. So we installed the dependencies. It creates some new files for us, so we can go back to the presentation. We can see that it created this hard hat config file. So basically here is where we're going to configure which chain we are going to use. We can get rid of this. The first thing that I'm noticing here, the solid version is different from the we have here, so we have to adjust that. And also I'm going to require here the .env, so we're going to use .env to load our private key to this file. So I'm going to declare here the network that we're going to use. In this case, we're going to use the Mumbai, that's the testnet uh, the testnet for Polygon. So we need some URL. The URL is the node that we're going to talk. So we're going to send our transaction to this node. In this case, I'm using the node from Alchemy. You can go there and get like a API key for you to deploy your contracts, and also the accounts here. We're going to use the private key that's on my .env. Whoops. Process .env .private key. So we have to create the file here, the .env. I'm just going to copy from another project here, the private key. And then that's my private key for this. So with this, we can change the sample script. So we already are able to connect with some node on the network. Right now, we need to deploy the contract. So it's a pretty simple deploy script here from hard hat. We just have to change the name. So instead of greeter here, it's your token name. So in this case, it's my token here. And also the deploy doesn't have a parameter here because we're not passing anything to the constructor here. So with this, my token deploy to this address, so we can go back to the terminal and run the command npx hardhat run scripts, the sample script, and then passing the network that we're going to use. That in this case it's Mumbai. So just wait, it will compile everything. It's compiling, and it will deploy the contract to an address. So we can see here my token deployed to this address. Let's take a look on the Mumbai polygon scan. We can see here placing the address here. We can see that the token was created like 15 seconds ago. So with this, we are able to get the contract address. We're going to put this as well on the .env because we're going to use on the next step, that is the React app. So next, public contract address will be this one. Basically a Next.js app. It's a mono repo, so we have the contracts and the app here, so it's make life easier. So I already have the dependencies installed, and I'm going to first first thing I have to do is to the public folder have like the JSON files and the images. So I'm going to the hashlibs and copy that and paste it here. With that, we can go to the API and create a route to serve our metadata, because in the end, that's basically your NFT. In the blockchain, there's a link for this API. So the API will have the information that we need. That's basically that NFT. So we're going to create a folder here called NFT and also a file with the IG. I'm going to copy from the hello. I'm going to get rid of the types here. So the first thing that we are going to do is have the ID from the query parameters. So ID will be a number, and also the file. The file we have to read from the disk, so we are going to use fs to read the file. Await promises read file, and then here it will be the 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 path to the thing that I just did here. So it would be dot public JSON and then the ID dot JSON. I have to say it's a sync as well. And then from that we can get the JSON with JSON dot parse here, file to string, and then here we're going to send the response here will be the JSON that we just read from the disk. So basically this is our API. Let's see if it's working. Let's run the server here. Go back to Google Chrome. We can see that welcome to next, and then we can go to api.nft /1, and we can see that there is my first NFT, so it's working the API to fetch the metadata. So the next part would be having the wallet. So the user on the app, the React app, interacting with the app. So the first thing that we're going to do is go to the app and use the framework that I show you, the use wallet, to connect with the wallet. So we are going to use here, we're gonna have here the use wallet provider. That's basically how we can know in the app that the user is using a wallet or not. So we can go back to the index here, and then here we can use just the hook, use wallet. I mean wallet, and then use wallet. And we can oops, that's not array. Oops, I'm having some problems with my keyboard. That's not an array, that's destruction. Oh, there's not. That's just a hook. I'm sorry about that. And then we can go here and console log the wallet. And if we go back to the root, we can see here on the console that it printed the thing, but is not connected. It's not connected to anything. So after that, we have to connect our wallet to we're using like some MetaMask or something. So the first thing that I'm going to do is create a method to connect our wallet. So let's say it's connect wallet. It's a return await window. We have to access the window to have the Ethereum. So there is where the MetaMask or other browser extension lives. Request. So we're going to request something to the window. In this case, it's a method wallet add Ethereum chain. So in this case, what we're doing here is calling a method that we will add this chain if it's not there, or we'll just connect it. In this case, we have to pass also the params here. The params I'm going to copy, but there are the parameters from the chain we're using. In this case, we are using in this case we are using the Matic chain on the Mumbai. So that's what I'm connecting to. Here is the chain ID. It's like the Mumbai. So with that, we are gonna have to create like a button to connect. So I'm just gonna get rid of this welcome to next and just place a button here. Let's create a button with the class name. Let's just have some styles here. And then on click, we are going to call this method that I just called, that I just created. Just missing something here. So yeah, here we're gonna call it connected wallet. And then also here we have to inject in the wallet, so we have to call this connect. So we are connecting the wallet by some injection. And here just like say connect wallets. So we can see here that we have the button. I'm back. I had a little problem, but we can see here that we have the wallet here, but it's not connected. And then right now, when we click the connect wallet, we can see that it has the account and also the balance. So we need the account to see from where we're going to send the transaction. So the next step is like to create another page for that. So I'm basically gonna do really simple thing. Just like doing an if it's not a wallet is connected. Now we're going to return this. Else, if it's connected, then we are going to return like the same thing, but here instead of connect wallet, we are going to claim our token, but we don't have this yet. Just let me see if it's working. And also we can change this from like here we can instead of having this welcome to next, like a studio awesome NFT, and then when it's connected we can have a message like mint your awesome NFT here. So yeah, we can see here and then when click connected it changes and to the claim, but we don't have the method to claim yet, so we're going to have to use the Web3 uh, directory package that I have already installed to call the Web3. So in this case we are going to have to use some hook to have the Web3 and the methods there. So I'm going to create a folder here, hooks, and also a file here use contract methods. Yes, so the first thing that we have to have here, um, it's the Web3, because the Web3 is the way we communicate with the blockchain. So we have to instantiate like the contract, passing the ABI. That's the methods that the contract talks, and also the contract address. So that's the first thing that I'm going to do. So I'm going to create this hook to be used internally here. So it will have like this Web3 instance here. It will be any for now. I think we can use that. And also you're gonna use Rev from React here. And also the contract as well. Let's say it's any. And also use Rev. So our life is easier. And we have to use effect here because of server-side handling. On the server, there is no window, so we have to use the use effect so it knows it's running on the front end and it's not calling this method on the back end. So the Web3 current will be new Web3 and window.ethereum. So we are getting the window here uh, using the MetaMask. We are using here the MetaMask provider to be our provider to our version here of the Web3. So I'm going to import that. And also I'm going to instantiate the contract as well. So we are going to use, we're going to create a new instance of the contract. So it's new web3.currency.f.contract. And here I'm going to pass the ABI of the contract. So it will be my token.abi. We don't have this yet, but we'll have. And then process.env.next public contract address. So let me import here. Import my token from the artifacts, then contracts, and then my token, and then my token.json. Here we can see it has the ABI, which is like the methods that we can call. So we can call like this method here, like approval for all. We can have like transfer, like everything, like the balance off. We can know this from this JSON what methods we can call. So with this we have an instance of the contract here, and we are going to return the contract. So with this we can create the hook to create the methods that we want. So we're going to export this and call use contract methods. We will have like the contract that we just created from there. We use Web3. So with this we can like call the methods from the contract, and also we need the wallet that we used before. Let me import this. And then here we can create a method called clang. That's the method that we want. It's async. And here we're gonna just return the contract current. We have the methods here, and also the clang. And we will send here the parameters are from. That's the wallet that we are using, and the account as a string, and also the value. That's the amount of money that we are sending. That will be the price. The price here we don't have as well. I'm gonna define here as const price. It will be 2 E17 because here it's in way and not the ether. So 1 ether is equivalent to 118. So in this case it's 0.2. So it's this in way. You can see the conversion on Google, like way to ether. It will explain the converter here. So 1 ether it's equivalent to this. So we have the price here. Basically that's it for the clang. We can use this on the front end, then on the home component. So we're gonna have to import as well the clang here. We're not returning nothing here. So I have to return clang. So here right now we can use here to call clang, then wait claim, and then we can go to the app and see once let's refresh. if you're connected, when we click claim, it should open the MetaMask wallet. So it's opening the MetaMask wallet and expecting me to send this amount of money to this contract. So I'm going to confirm, and it seems to be working. We can see in the activity here, it's pending. So yeah, it worked, but we don't have any idea what happened because we don't have any way to see the NFTs that I have from this account. So this is what I'm going to do next, showing the NFTs here. So the first thing that I'm going to do is create another method here on the hook, so we can get the user tokens. So let's call it get user tokens. Here we're going to use the methods from the enumerable. We're going to call also the contract here to have the balance uh, balance of owner, and we're going to call it, and then we're going to create a for loop here to iterate over, and here will be the balance, and here would be the token. We have to call the method as well. Token of owner by index. That's the method I said that we have from the enumerable. And then we're going to push to this array here. And also increment the index. And then return the tokens. So yeah, we don't need to understand this part of code. It's just like something to get the user's tokens. So we're going to grab this from the hook as well, and then let's create like some kind of way to know when we're gonna get the users. So I'm gonna create like a pooling. So every second we will like fetch this from the blockchain. So I'm also going to create here a use state here with the tokens and set tokens. And then I need to have a use effect. So we can create like this set timeout here, this set interval actually. So the array of dependencies will be the wallet and the account and also the get user tokens. So we can say if wallet account we do something, will be like getting the timer ID here. It will be async here. And then we're gonna fetch here the response from the get users token and set it to my state here. And then we're gonna return to clear this interval. Oh, he's complaining that we're not exporting this here. So yeah, get user tokens. So here TypeScript is complaining as well. Let's just avoid TypeScript right now. And then just like just print the res here to see if it's working. So it is, because we can see here that we have the 0 here. So if I claim another one, I should see that it increases. Yeah, 0 and 1. So yeah, that's working. So right now we just have to show to the user these NFTs. So I'm going to create like a map here to show it, mapping the tokens. Let's create a div. Let's create a div here, and also the image from next. We can have like this, and then here will be source, and then here I will pass the the um, the path to the public that I put the images there. So will be token.png. I guess we have to put here images first, and then this. It's complaining that we don't have here, so I'm going to say image plus token. And also I have to pass here the width, the height, and also an out here, my NFT. So it's complaining about something here. Image. I think I'm not importing from next here. Just let me grab here. Now we import from next, and then it will be fine. So yeah, with this, we can also, after the image, just print as well the NFT number here. Whoops. So with this, we should be able to see the images. Yeah, we can see the images that we're claiming here. So if I claim another one, it should work as well. For some reason, it's not working. No, it's just working. Yeah, it just popped this one. So yeah, it's working. Here we're claiming and minting our NFTs that we generated with the Hashlibs art engine. I know there's a lot of things going on right now, but my idea is here was just to show you guys some basic how it works. There's a lot of things that could improve in the process here. It's just like showing that is everyone can do it, and it's really nice and really simple to publish something there. And let me know, guys, if you have any questions.